So welcome to Cryptography 101. For those of you who weren't here at last week's workshop, my name is Samin and I'm going to be your mentor. I'm also joined by Annabelle and Adam, who will also be mentoring, and they're going to be monitoring the live chat. So at any time, if you have any questions, then please feel free to send it to them, direct it towards them, or you could send it to everyone in the chat. So here is an important piece of information that I have for you guys today, that moving forward, we will not be using the Piazza platform for the students only. All the students are going to be taken off. The teachers and community supervisors will continue to use the Piazza platform, but the students will be taken off. And once all the students are taken off, an email will be sent to your community supervisor as well as the teacher. If you have any questions, please direct them towards your teacher or community supervisor. They are going to direct it towards us, towards the mentors, and then we will answer it from there. So please just note that we will not be using the Piazza platform for the students moving forward. So overview of Cryptography 101. Here are all the topics we're going to cover today. We're going to talk about what is cryptography and why is it important in the world of cybersecurity, and just why is it important in general. We're going to talk about encryption algorithms, history of cryptography, substitution ciphers, transposition ciphers, and we're going to take a little break in the middle and we're going to play a little game. So stay excited for that. And we're going to talk about symmetric encryption, asymmetric encryption, and we're going to also talk about hashing. So this is a general overview of everything we're going to cover today. So just out of curiosity, how many of you are familiar with cryptography, or how many of you have actually done some cryptography type of challenges or just have read something about it? If you are, please let me know in the chat. I'm really curious to see if you guys have heard of it before or have done any work with it. Okay, so there's a mix. There are some people who haven't really done anything. There's some people who have a bit of experience. And there's a question in the chat, which, did you explain yet what cryptography is? No, we're going to go over that in just a couple of seconds. Okay, so that's good. So there we have a good mix of people who know what it is. Some people have done some work with it. So so by the end of this workshop, you're gonna understand what cryptography is, what it's used for, and how you could solve some of the CTF challenges that you might face during the competition. So what is cryptography? Cryptography is basically taking a message that is understandable to humans and converting it into a form that is not understandable by human beings, so that it protects and it conceals the message. And if you want to use the actual jargon, it's encrypting data from plain text to ciphertext so that it can only be read by the intended recipients, and decrypting data then from the ciphertext to the plain text so the people that are meant to view that data can view it. Now, why would cryptography be important? Like, why would somebody want to conceal a message? Does anyone know, like, why is it important to hide that data or to convert it from the original text? Like, what are some applications and why is it important? Protecting your programming, your code, correct? Yeah, and there's a lot of actually applications. Everything that we do is on an open network. For example, the internet. We are sharing information like our credit cards. There is medical data that is being shared. We don't want everyone to have access to that data. There's a lot of confidential information that organizations hold. One of the biggest chunk of confidential information is your medical data. You don't want everyone to have access to your medical data. It should not be stored on, in plain text online. Like, I should not be able to see all of Adam's medical history, like what tests he got done. That's not a good idea, right? So we should encrypt it in a form that only people who know the key to decrypting that data can access it. So that's why cryptography is really important. Cryptography falls under the umbrella of cryptology, and alongside cryptography, there's also cryptanalysis, which is the study of ciphertext ciphers, cryptosystems, and usually people who study cryptanalysis are finding ways to break those systems to see how they can be further secured. So now let's talk about the importance of cryptography. We talked about confidentiality. It's really important to ensure that the data can only be seen by the people who it is intended for, right? We don't want everyone to see our medical data. We don't want everyone to be able to see our credit card information. We don't want people to see our pictures, our selfies. Like, there is so many applications. So it's really important to protect that confidential integrity. Integrity is ensuring that the data that you received has not been altered or tampered with. For example, if I'm going to share a file with you and that file is secret, you want to make sure that the file that I'm sharing with you hasn't been taken over by a hacker and they've added their own code to it, or they've added something wrong, they've taken out important information. You want to make sure that the file that I sent you or the data that I'm sending to you has been untouched and is in its original form. So it's really important because cryptography provides us with integrity. Two concepts which are beyond the scope of Cryptography 101, which we will cover in further detail in Cryptography 201, and are non-repudiation, which is making sure that the sender really did send the data. So the person that is on the other chain, on the other end of the connection, did really send the data, and they can't say that they didn't do it. And we can prove that with cryptography. We can prove that someone actually did send that data. So that's important. And authentication, it's a process of proving your identity. So those two concepts are outside of the scope. The non-repudiation authentication, we will be covering those in more detail in Cryptography 201, which is going to be in the next year. So now let's talk about some important terms that I've been mentioning. Plain text. So plain text is original text. It's readable by human beings. It's something that we can understand. Ciphertext is text after it has been encrypted. So if you were to look at ciphertext, it would be a bunch of random letters or characters you wouldn't understand what it exactly means. So ciphertext is after it has been encrypted, after an algorithm has been applied to it. What is a cipher? A cipher is an algorithm or technique for performing encryption or decryption. Algorithms are mathematical formulas that are applied to your data so that it shifts the data, it converts it, and it makes it into ciphertext. And what is encryption? Encryption is the process of converting that plain text into ciphertext. And then decryption is the process of converting ciphertext back into plain text so the people who are meant to read that data can decrypt that data and read it. So I have a few more important terms. So what are keys? So keys are a string used in combination with a cipher with an encryption algorithm to transform plain text into ciphertext. Keys are the key of cryptography. No pun intended. They are literally the key for cryptography, because without knowing the key, ciphertext cannot be converted back to plain text. But what's more important is the key is what keeps your message confidential, because everything, the crypto system that is being used, the algorithm that's being used, and even the algorithm you're using, that's all public knowledge. What's secret is the key. So it's really important to protect the key, because the keys are what adds uniqueness, and it's what allows us to really encrypt that message with secrecy and make sure that nobody else can decrypt that message who doesn't have the key. So key space. So key space is a number of possible keys that can be created from an algorithm. So the larger the key space, the more secure the algorithm. Of course, this comes with so the larger the key space, it will also require more computing power. So there's a trade-off there. But the larger the key space, the more secure the algorithm. For example, if you have an 8-bit key, then you have 2 to the power of 8 key possibilities. But if you have an algorithm that's 128 bits, then you have 2 to the power of 128 possibilities for the keys. So the larger the key space, the more secure the algorithm. So now let's talk about algorithms in more detail. Let's talk about encryption algorithms. So Kirchhoff's principle states that the security of a crypto system must lie in the choice of its keys only. As we mentioned, everything else, including the algorithm, is public knowledge, right? So it's really important to have that key and to secure and protect it, and to make sure that key cannot be brute force. So a large key is good. And so what exactly is an encryption algorithm? Well, an encryption algorithm is a mathematical formula that's used to transform that data into meaningless ciphertext. It does a bunch of math, and we're going to see an example on the next slide. It has a bunch of functions that it follows, and it converts that text in that data using that mathematical formula to give us the ciphertext. It works in conjunction with the key. So on top of the algorithm, the key is also applied. And if there be no key, then everybody else would be able to read that message by decrypting it using the algorithm. So it's really important that we use protocols and algorithms that are widely used and heavily analyzed and accepted as secure. So nobody creates, well, majority of the people do not create their own encryption algorithms. They trust public algorithms that are available because these algorithms have been tested for years. They have been analyzed by cryptanalysts. They are known to be secure, and majority of the world uses these algorithms to, encrypt their data and trusts them. The power of the algorithm, the secrecy lies in the keys. Again, as mentioned, the longer the key size, the harder it is to brute force. However, the larger the key size, as mentioned, more computing power is required. So some commonly used algorithms include DES, AES, RSA. Now RSA is used because it's more common. The key size is much larger. It's a much more secure algorithm. There's also triple DES. DES is not in use anymore, but it was one of the most commonly used algorithm. Now, there are two types of ways that these algorithms can work. Either it could be a block algorithm or a block cipher, or a stream algorithm or a stream cipher. So what a block cipher does is it encrypts a block of data. Let's say you have 32 bits of data. It would encrypt that entire block. So the encryption happens on the whole block of data. Some examples of a block cipher are DES, triple DES, AES, and then there's a stream cipher, which is a single bit of data that is encrypted at a time. Some common stream cipher algorithms include SEAL, RC4. The more common, most of the algorithms are done using block cipher as compared to stream cipher. Stream cipher comes from actually the word streaming, so it's used in a lot of streaming services. It encrypts data bit by bit because stream ciphers tend to be faster than block ciphers. The block and stream ciphers are kind of beyond the scope. It's important to understand them, but it's not important to know, the mathematical details behind them for cryptography 101. Let's move on. And this is what a cryptographic algorithm looks like. It just performs a bunch of functions. So here you have the key. There's a loop function, you shift the row, you sub the bytes. There's a lot of different math being done to the key to change it around. And in the end, you end up with the data that is a ciphertext that's unintelligible. Now, the important part is the key, which is right here, because if the key is not added, the key is what's the unique piece for the algorithm. Without the key, everyone can easily decrypt the ciphertext and understand the message. So the key is very important. So now here is a graphical depiction of what happens during encryption. So you have your plain text over here, and we encrypt that using an encryption algorithm. Let's say we use triple DES. So we're going to have triple DES, but to encrypt that data, we're going to use this key right here, which only I know this key. I'm not going to make this key public knowledge. And I'm going to share a message with Adam. So I'm also going to share the key with him because he's going to need to use the key to decrypt the message. So I'm going to send Adam a secret message. I'm going to encrypt it using triple DES. I'm going to add a key on top of that. Now, Adam knows the algorithm that I have used. He knows that I've used triple DES, and he also knows the key. So having that, he can decrypt that ciphertext back into plain text. If he did not have the key, even knowing the algorithm, he would not be able to decrypt back from ciphertext to plain text. So the key, again, I've emphasized it so many times, the key is key. Okay, so now let's look at the history of cryptography. So cryptography literally means hidden writing. It comes from crypto, which means hidden, and graphy, which means writing. And I think these are Greek words, and it literally translates to hidden writing. So the first, not the first, but one of the earlier instances of cryptography being used was back when the Egyptians used to communicate secret message using hieroglyphs, and the code was only known to the scribes. So the code, which the key, was secret. And then Julius Caesar in 100 BC came up with a way to communicate with his army generals using a secret code. He didn't want the army of the opposition to be, eavesdropping or understanding the commands that he was giving to his army. So he used what is now known as the Caesar cipher. And we're going to be looking at that Caesar cipher and how it works. So this is what a Caesar cipher looks like. Here we have our plain text. We have the letters of the alphabet, and this is the ciphertext. The key in Caesar cipher is substituting each letter with the third letter in the alphabet. So for example, for the third letter after it. So for example, A becomes D. So 1, 2, 3, A becomes D. B becomes E. So 1, 2, 3, B becomes E. So Caesar cipher is also known as a substitution cipher, and you substitute one letter of the alphabet for another letter. So let's see how this would work. And let's look up Caesar cipher. I'm going to use this website to demonstrate. So let's say that, let's just type out cryptography. So cryptography, let's put it back to 3. So the key is 3. If you don't know how many letters are being substituted for, then you don't understand. For example, if I gave you this ciphertext right here, but I didn't tell you the key, let's change it to 3. Let's see here. You just copy that, and let's make it like 2 or 1. Let's say you didn't know the key, it would be hard for you to figure out. Like if I didn't tell you the key was 3, so you could try the other ones. With this one, you could try all of the combinations and you'd eventually figure out, but the key is what would make it secret. It's how you know that you have to shift the letters by 3 spaces. So again, so when you decode it, if you go back to 3, it gives you cryptography. So here we're using the same key. The same key that we're using to encrypt the message from plain text to ciphertext is the same key that's being used to decrypt the message from plain text to ciphertext, and the key is 3. So let's go back to our presentation. So that is what a Caesar cipher looks like. And in all the CTFs I've played, and I've played a lot, there is always a Caesar cipher question. Like 100%, there's going to be a Caesar cipher question. And they might not give you the key to make it more challenging, but there's only so many substitutions you can have, so you could easily guess. So another substitution cipher is also known as rot 13. It's rotate by 13 places. It's literally the same thing as Caesar cipher. The only thing is it's now being replaced. The letters are being replaced with the 13th letter after the alphabet instead of 3 letters. So A becomes N, as N is the 13th letter after A. B becomes O, C becomes P, and so on and so forth. So for rot 13, it's basically the same thing as the Caesar cipher. It's only 13 places. So let's see how that would look like. So here's a website that is really good to encrypt and decrypt. You can use these websites while you are doing your CTF challenges. Another easy one is CyberChef. Let's see if it pulls it up right here. CyberChef, they have rot 13. Let's use CyberChef. So I'm going to put cryptography, and this is the output I'm going to get. And then if I take this and I use that same, I put the ciphertext in right here, I'm going to get the same output because The key is 13, and this is using the same key to encrypt and decrypt. So let's go back. So that is ROT 13. Let's look at the Veneer cipher. So the Veneer cipher is a little bit more complex. It uses a 26 by 26 table for all the letters of the alphabet, and it has rows and columns. So, and this was one of the questions in the PICO CTF last year, so it might show up again. So how does this work? So let's say we have a sentence. My sentence is, I love cryptography. So I'm going to use this table to encrypt that message. But I need to come up with the key that I'm going to use, and you can create your own key. So the key that I created is CanHack. Now, for it to work, you have to repeat the key for as many characters as your sentence or phrase is. So my phrase is 17 letters, not including the spaces. So I'm going to make the key 17 letters and repeat the key until it equals 17 letters. So the key is CanHack, CanHack, can. So now how I'm going to do this is I'm going to look at the I and the C. So it doesn't matter if you go row first or column first, it'll give you the same output. So let's just look at the columns first. So let's look at the column of I, and let's look at where it intersects with the C row. So right over here. So that I becomes K. Now let's go back to O, and we're gonna correspond the O with A. So we're gonna go right here, O, and where does it intersect with A? Where does it, the L and the A, not the O. So where does L intersect with the A? At L. The O and the N. So where does O intersect with N? It is right here at B. And so doing that would give you this ciphertext right over here. Now let's say you get this ciphertext and you have the key. How could you decrypt this message back to I love cryptography? So what you're going to do is you're going to now have to use the letters inside the table and correspond them with the rows or the columns. So let's see, the key is C and the first ciphertext is K. So I'm going to look for C and see where K intersects with C, and that is at I. So the first letter becomes I. For the second one, it's L and A. So now I'm going to see where L intersects with A. So I'm going to go in the A column, and L intersects with L. So I'm going to write L. Then for the B and N, I'm going to see where the B intersects with the N. So I'm going to go right here. B and N is right here. Sorry. Yeah. So this can be a little bit confusing. So the key is N, and it has to be at B. So N is right here, and where does it intersect with B? At O. And so if you follow that, you would be able to decrypt the message. It can be a little bit confusing, so it's important to remember how it works. So if you have the ciphertext, you're going to be using the letters inside, and if you have the key and the plain text, you're going to use the rows and the columns to encrypt the message. So that is a little bit about the Veneer cipher. Let's look at transposition ciphers. So in transposition ciphers, the order of letters is rearranged according to a predetermined method. So for this method, they've decided that they're going to use a 4 by 5 table. So what they've done is they've arranged it vertically. So this is a secret message, and they've written it out like that. Now your ciphertext becomes this whole thing going this way, going horizontally and then down. So in this case, if I were to share the ciphertext with someone, what would I tell them? Like, what would I say the key is? Does anyone have any ideas of what I would say the key is? Let's see. Yeah, correct. It would be, yeah, so the width of the table, the length 4 by 5. Yeah, exactly. So you would specify the table and the position of the letter, and that would be the key. So as you can see, without the key, I mean, it's not that hard, but without the key, it would be hard to decrypt the message. For this case, it's not that hard, but you can have it in a weird sort of way where it becomes hard. So it's important to have the key to decrypt the message. So that is what a transposition cipher is. So now we're going to talk about quickly symmetric encryption and versus asymmetric encryption. So symmetric encryption is what we've been doing so far. It's when one key is used to encrypt plain text and decrypt it as well. For the Caesar cipher, both that key of +3 is used to encrypt the message and decrypt the message. So the key is shared among the receiver and sender of the data. So I was sending you guys the data and you were the receiver, so I shared that key with you. Without that key, it would have been hard for you guys to decrypt the message. So symmetric encryption uses a shared key. It's really important that the keys are protected at all times. Example of symmetric encryption is Caesar cipher, AES, DES, triple DES. We're going to be going over symmetric encryption, specifically the algorithms and the mathematical way that they work in more detail in Cryptography 201, which is going to be next year. And asymmetric encryption is also known as public key cryptography. So asymmetric encryption involves a key pair that are mathematically connected and work in conjunction with one another. So you're going to have a private key and you have a public key. So let's look at these locks right here. So this open key right here is the public key, and this locked is, let's say it's the private key, even though it's a lock, but let's just say it is. So this is the private key and this is the public key. So what's going to happen is that the public key, as it states, is public. So public key is knowledge to everyone. So I'm going to have a public key. So if you guys want to share a message with me, I'm going to share my public key with you. So you're going to use my public key to encrypt the message you want to send to me and send it back to me. So I'm going to receive a cipher text. I'm going to use my private key now to decrypt that message. Now, only I can decrypt that message because only I have my private key. So those keys work in conjunction with one another. If you want to look at another example, let's look at a mailbox example. So we have a mailbox and it has a tiny slot, and everyone can drop mail into that slot. So that is you can look at it as your public key. Everyone can drop information. They know where it is, they can drop information. But I only have the key to open that mailbox and retrieve all of that information. So without the key, without that private key, you can't open up that mailbox, and only I have that access to that. So I hope that makes things more clear. And examples are RSA, ECC, Algama, and we're going to be going in more detail about the math of it in Cryptography 201, and especially RSA and digital signatures. To the next slide. So one of the important concepts that I mentioned that cryptography is really important for was integrity, and hashing helps us with that. So hashing algorithms are one-way algorithms that cannot be reversed. So you cannot decrypt a hashing algorithm. It will not give you the plain text data. Hash is just there to make sure that the integrity is preserved. So what does that mean? So a unique hash is created for that data, and it's going to be so it's going to give you a unique hash. Now, let's say I'm sending you guys a file, and it's a medical file, and it's really important. It's confidential. It's really important. So I'm going to encrypt the file, but I'm also going to produce a hash for the file. So you're going to get that hash value. Now, before opening the file, you're going to compare the hash value and see if it matches. If the hash value that you have matches with the hash value I provided you, that means that the file has not been tampered with in transit, someone hasn't gotten a hold of it. That means that the integrity is preserved. Even if you change one bit of data in a file, it will completely change the hash value. Some popular hashing algorithms are MD5, SHA-1, SHA-2. MD5 is a weak algorithm, so is SHA-1, but they are still commonly used. So now we're gonna look at a demonstration of how it can work. So if you guys were here for the web security workshop, you remember these secret files that I had. So I'm gonna go into the secrets folder because there is a file here. And if you remember from last time, to reveal hidden files, it was ls-a. So here's a file called secrets.txt. Let's check the hash of what this file has. So secrets.txt. So this is the hash for this file right here. Now let's open up this file and let's make a small change to it. So let's add an exclamation mark. Let's add an exclamation mark right over here. And let's exit and save the file. So now let's run the same MD5 command on that file. Now, as you can see, just adding an exclamation mark significantly changed the hash value right over here. Do you see that? So it completely changed the hash value. You can even use a different algorithm. You don't have to use MD5. You can use a stronger algorithm where the key, you can see that it's longer. So you can use a different algorithm. You don't have to use MD5, but that's a way to prove file integrity and to make sure that file has not been tampered with. So that is a little bit about hashing. So we are coming to an end. So let's review everything that we learned in today's class. We talked about the importance of cryptography and how it's used to provide confidentiality and protect private data. It is very important. It provides confidentiality, which is so important. We talked about how encryption is the process of converting plain text into ciphertext, which can only be decrypted by the intended receivers of that data. Keys are what make encryption secret, and they must be protected. If you accidentally give your key to somebody else and they have the key to your data, they can easily decrypt the message. So it's important to make sure your keys are protected. Transposition ciphers versus substitution, where transposition, you're changing the ordering of the letters, and substitution, you're substituting one letter for another. And a really popular example of that is a Caesar cipher. We talked about symmetric encryption versus asymmetric. Symmetric encryption is when you have the same key for encrypting, decrypting data, and asymmetric encryption when you have a key pair, a private key and a public key. Everyone has access to your public key, so they can send you information, but you can only decrypt that information with your private key. And that is used a lot in like banking, for example. When you send the bank your credit card, only they can decrypt your credit card number to see it, not anybody else. And hashing is used for integrity to ensure that the file has not been tampered with. So now let's look at the resources. So here are some resources that are available for you guys. So Resource Hub is very important. It is where the recordings of the videos will be posted. And so it's important. And if you already haven't, signed up for Pico CTF platform, please do so you could practice some of the challenges from last year and, really get good practice in. And there's also a primer, which is really important to read prior to the Pico CTF challenge. It gives you a basic knowledge of everything you will need to know. Online tools for encrypting, decrypting are, this is CyberChef that we use today, and we also use Crypty. So I'm going to copy and paste this in the chat in just a second. But before I do that, are there any questions? The competition is March. I'm going to go through any of the challenges like I did last time. The challenges on the Pico CTF are very similar to everything that I did a demo for, like the Veneer cipher, the Caesar cipher. So we'll be going over more challenges in the Cryptography 201 workshop because those are a little bit more challenging. Is the key ever encrypted for super secure? Yeah, the keys also are encrypted. Somebody is asking if we do any work after these meetings or do we just learn during the meeting? If you want to really practice, you could use the resources that I provide. After each workshop, I provide some resources to strengthen your understanding. And for this one, I think it's really important that you go into the back end of the Pico CTF and you play around with the challenges from last year. And if you come across any questions, you could share that with your teachers, and your teachers can share that with us, the questions. RSA will be covered in Cryptography 201 because it's a more complex concept. So this was an intro to cryptography, and RSA will be covered in Cryptography 201. And if you do have any questions with any of the challenges, as we mentioned earlier, you could share those with your teachers. We'll be removing all the students off the Piazza platform, but the teachers will still have it to communicate with us. So if you have any questions, please share that with your teachers, and they can direct them towards us. Cryptography 201 will be in 2021. Can you quickly explain hashing again? Sure. So hashing is used for, it's a one-way algorithm that cannot be reversed. And what it does is it's used for file integrity purposes. So you're going to generate a hash for a file, and then using that hash, you can compare it. And if you ever change a bit of any, like even a little bit of data or 1 bit of data in the file, it will completely change the hash value, and then you'll know that the file has been tampered with. So I'm just going to demo, the Caesar cipher challenge that we did today, just because some people want to see it. So I'm just going to demo that quickly. And if you have any questions, you can continue typing them in the chat. Mentors are here to answer them. So I'm going to share my screen. So let's go back to this challenge right here. And let's copy and paste that. And let's go to Crypty over here. So when you have that, you can decode the Caesar cipher. So for decode, the key is the same. It's 8. And we're not going to go -8 because that would be going backwards. A would become S. We are doing a +8 key. So A becomes I. So we're going to put our Caesar cipher, our ciphertext right here to convert it back into plain text. And it should have been meet tonight at 7 by the secret door. So if you look, A right here became I, if that makes sense. So like it's really important to shift them at the right amount. And if they are not being shifted the right amount, then it might not work properly. I hope that helped.